Zaczynamy już? Startujemy? I see some people are coming still, but let's start. Welcome everyone. Unfortunately, I didn't make the going to the first day of the conference, so this is actually my first hour of this conference. But anyway, I hope you have a great time here. And today I will talk something about test-oriented cloud architecture. But first of all, my name is Wojciech Dąbrowski. I hold the role of AWS Capability Lead for Central Europe in Deloitte, and it means no more or less than I am responsible for supporting every project in Deloitte in Central Europe related to AWS. So every project in Central Europe which is hosted in AWS or consulted in AWS go through my hands. Besides that, I am AWS user group leader. I organize AWS user group Silesia meetups every 2 months, more or less. And I am the member of AWS Hero. This is the group of 200 the most performing people in AWS community in the world. First of all, I want to encourage you to write the session. Of course, not right now, just after the session. But it's for you. It's just to remember that. And short disclaimer about this presentation. First of all, I encourage you to be active during the presentation. So if you have any question or do you have any comments regarding the stuff which is presented, you are free to raise your hand and ask about something or say something. And there will be some controversial stuff here. It is not the dump from the documentation. There are some opinions, my opinions, about building the software, about testing the software. So it is actually welcome to not agree with that. and we will talk about this afterwards or during the presentation. So surprise, we want to talk about the testing, but let's just talk about the testing. So this is the question for you guys. What is the purpose of automated testing at all? Why do we want to have automated tests or even just the tests? What do you think? Okay, something is broken, but at which state? Okay, so when we introduce new functionalities, or at which stage, actually? Okay, but it is about the new functionalities or maybe the old ones? This is the question. Okay. Yeah, that's correct. Okay. Yeah, every comment is valid. Actually, the most common purpose for testing and pointed just always is verifying the new code. So we are writing the new functionality, and we verify if it's working as we expect. So it is pointed very often. But actually, the most important thing of automated testing is checking the regressions. So if we introduce some new functionality, we are checking if we are not breaking the old one, which allows us to new features, but also refactor the code or architecture. So in this world, we quite often refactor the architecture, maybe changing the database, maybe changing the integration with other services, maybe changing the serverless to containers, changing the configuration of them, and we want to test the refactorization also. And the last one, and you didn't mention that, writing the tests in our code, in our application, validates if our design of the whole system allows us to do so. So if we are not able to write the tests for our application, our architecture, it is, you can say, some code smell or architecture smell regarding the design of the whole solution. Okay, so let's jump to automated test types. So we have a number of various types of automated tests. You may be familiar with that. It is quite common test pyramid of automated tests. And on the bottom, we have tests which are the most common, should be most common in our applications. And going up, the tests are less common in our design. And the inverted, and of course, we will go through all of types, but not now. We have also the reverted pyramid, which is called as an anti-pattern of that. When on the bottom we have unit tests, and on the top we have manual tests, which are not so good practice. And of course, going up in this level of abstraction, we have the slower tests from the perspective of writing them, but also running them in the runtime, but also the more expensive in writing and running. Okay, I want to prepare some classification of tests with you, basing on the very simplified architecture of actually every microservice or every component that you can meet. Actually, every piece of software, microservice, or or even a monolith or some component is composed by some code modules, and almost in every case, external data store and external services which are integrated with this module. Okay, and first type of test is unit test. What do you think? What is the purpose of unit testing, and what is the scope of these tests? Any idea? Yes, that's true. But what is the purpose of them, and where we write it, and what are we checking with them? Mm-hmm. Okay, there is no very strict definition of unit tests, but as you said, it's the smallest possible tests that are testing the smallest possible thing. So it can be the scope of unit test can be the single function, the single class, for example, or single method in this class, but it is always the thing that is located directly in some of the modules in the architecture. So unit testing is very handy when it comes to verifying the so-called business logic, for example. When you have some rules of calculation things, when we have single calls to something or something like that, it's very handy. Integration tests, and actually it is the most interesting type of tests, because it is, I think integration tests have a number of definitions in our industry. And I want to ask you, how do you understand integration tests? what are tested in integration tests? What do you think? Okay, good. This is continuous integration, actually. so it's not about testing, but about the integration. But yeah, okay. Okay, I am very proud of you, actually, because it is exactly the thing that I understand integration tests. But so the point of sticking together and the contract of the components that are talking to each other. But it is very common to understand integration tests as the flow of the whole application. It's really it's often understood like this, but it is not. In integration tests, we are testing the contracts. So if our understanding of integrating with the other system or other component is correct. And of course, we have integration tests, for example, with some external API or external service. And external is not meant that it is not managed by us. It can be third party, but it can be our other microservice. And for example, we use some data store. Okay. And talking about the unit tests, we have the unit test here, and the integration tests are boundaries with external services, external data stores, or external APIs. The next one, component tests, and maybe you are not familiar with that, but component test is the test that are testing our flow of our microservice or our bounded context, but with no integration with other services. So we are testing if the whole logic in our application is working correctly, but not taking account the external services, external integrations. Why do we want to test it like this? It's very easy because you want to verify if we didn't broke anything. We don't want to have the information about the whole flow, but we want to have the information about if we changed everything correctly and our application logic is working correctly. So this is the next type of test. In this type of test, we can use also the stub services, which are more or less the service that is serving the needed information for our system, but it's not the real implementation that is used in the production or in test environments. And the last one type of test is end-to-end test. And maybe, as you predict, it's tests that are testing the whole flow of our microservice. So we are using it to verify if everything what is deployed is working correctly and as we predict. And of course, often it is not about testing just one microservice or one stack and one component. It's very often connected together. So we are going to the whole environment. We treat it like a black box. We throw the request, for example, and we are verifying if everything is working correctly. And summing it up, we have unit tests, we have integration tests, which are testing our integrations. And we have the whole flow test called component test without the integration with external services. And we have end-to-end tests which are testing the whole flow, taking into account the external services. And translating those types of tests, this classification of tests, because there are some other classifications and definition of tests. But taking this classification to the test pyramid, we should have the most used unit test, automated test should be unit test. The next one, integration, component, end-to-end, and some exploratory, for example, some manual tests to verify some functionality or just explore the system. Okay, summing it up, we should use unit tests to verify the single function, and it's very, very handy to test the business logic. It is the fastest test to write and fastest test to run. Integration tests the integration with other components, but understanding it as a contract or some API. Component tests verify the behavior of our whole business logic inside our microservice. For example, single command, single query, single API call, or something like that. And end-to-end tests verify the behavior of the whole system. So we use it to verify deployed software in most cases. So every other test type works on the code, but in end-to-end tests, we work on the whole deployed solution in the development environment, in production environment, or anywhere else. Okay, and right now, some practical tips about writing tests. Sorry. Sorry, guys, it's hard to breathe without the nose, but I think I will be okay right now. Some practical tips about writing tests, various types. Starting with unit tests. When we are writing the unit test, as we said, we focus on the single functionality or single function in the one of the components. But you tell me, what happens if the unit test is touching something that is integrated with other module? Okay, mock it, and it's very, very, very good idea. But do we have only mocks, or some other tools or some other entities that are helping us to mock the functionality? There are only mocks, or okay. So this is called test doubles, actually, and it is mocks, but not only mocks. And I will just tell you about other entities that are helping us writing the unit tests, which are not exactly the mocks. And I will tell you what is mock. And in test doubles, we can classify fakes. One of test doubles are fakes, and fake is the entity that is replacing our external dependency that is not the real one, but it fakes the functionality. So the good example of the fake is in-memory database. So if you are using the application in the real environment, like production tests or so on, you use the real database. But for the test purpose, you often want to have the fake implementation, which is working somehow, very close to the real one, but it's not real. Stub, which is more or less the test double that are returning the value that we configure. we want sometimes have some stubbed value, some configured value that is returned from the external service that we are stubbing. For example, always return from the API the JSON with the contract we are expecting to prepare some tests. And mocks are the more sophisticated test double, because in mocks we want to verify not only that not only to configure the returned value, but also verify if the mock is called with our expected values. So, for example, when we are writing the unit test, we want to, for example, verify if the external function is called exactly 2 times with exactly payload which we are expecting. Okay, and in the presentation there is a word cloud, and I am not talking about the cloud at all for now. But right now we are starting with that. The surprise is I will talk about AWS, and the question for you: are there any AWS users here? Oh, nice. Very good. So I will talk about AWS, but it translates to other clouds also. So I will use some AWS services, but they are not. This is not strictly for AWS, actually. And about writing the unit tests when it comes to the cloud, what is changing actually? Because let's think if anything is changing at all. Were we writing the tests for cloud or not cloud? Let's assume we have very simple architecture. For those that are not familiar with AWS, AWS Lambda is a type of serverless function. So we can upload the application code here, and it serves as a single container. And this AWS Lambda is integrated with API Gateway, which means that we can call this Lambda from as an HTTP service, and this Lambda is integrated with S3 and DynamoDB. S3 is object store, DynamoDB, NoSQL database. And the question for you is, where in this setup we are writing unit tests? That's correct. So the unit tests are written here. And what's with the external services that are connected with that? So we are writing the test again against the logic which is here. But what with that? What do we want with? Yeah, that's true. Mock or stub, actually. So we want to check if those external services are called by using the mock, or we want to configure some value that is configured for the purpose of test, and we want to use the stub. Yes, you can use fake, but for the purpose of unit test, it has no more value than stub, actually, because you just want to. Yes, for unit tests. And how to write tests and how to write the software, it is beyond this presentation scope. So I recommend to use the clean code and go further with that. So we will not focus on that. When it comes to the integration tests, we are interested in testing the integration between the Lambda code and S3, for example, or DynamoDB. But still, we are writing the tests that are against this code here. When it comes to the component tests, I will just refresh that it is the tests that are testing the whole flow of our application, but without taking into account the external services. We are, or maybe it is the question. If you are testing everything in our application flow, but without external services, what are we testing actually here? We are on the component level, not end-to-end yet. Yeah, so which part? Everything? Everything, or still Lambda only? Yeah, it's still on this level. And what are we doing with those external services that are connected with the Lambda? Yeah, but with fake. It's very important because we want to have the real implementation that is working somehow, but not the end one. So we don't want to integrate with S3, for example, because it's not predictable that if it's working or not. We want to use the fake that are behaving similarly to S3 or DynamoDB, but it's not this. And how to write those tests? Again, it's beyond this presentation scope, but the code architecture is crucial here. So in writing unit tests, we are interested in clean code. In writing component tests, we are interested in the code architecture. So there are many models and ways how to write the application code to be possible to write component tests. Some of them are the onion architecture or clean architecture, and probably the most known one, the hexagonal architecture for some adapters. Maybe you have heard about it, but if you didn't, I encourage you to learn more about it. And when talking about end-to-end tests, it is the tests that are testing the whole flow, but against a deployed application. How is your idea right now? What are we testing here? Yeah, everything. And to test everything, we need to deploy it to some environment. Probably not the production one, or maybe sometimes. So we want to duplicate actually multiplicate our environment, our deployment, beside the production one. So we want to have, for example, development test environment, but actually it's not like it's not only test and dev environments. We want to have the possibility of creating the environment on demand, actually, to test the single functionality of the single commit and so on. So what do you need to prepare this testing environment? Requirements are actually clear. We want to have the repeatable deployment of the whole so-called bundled context. It can be microservice, it can be the whole application, it can be some part of an environment. We want to use parameters in our deployment. For example, we want to customize our resources. We want to inject some configuration of components. We want to adjust some dependencies that are used for this software. And we want to have the infrastructure changes. We want to have integration with our code application, the changes of the infrastructure. And what do you think? What tool or approach is ideal for that? It is the concrete. It's the particular solution, but in the big picture, it's infrastructure as a code approach. So we want to have our infrastructure described as a code in our application, ideally in the same repository with the code. And we can use various of solutions. Terraform is one of them, but actually in this presentation I will show the examples of CloudFormation, but it's not very important here. And when it is not possible to create the environments on demand. So when the infrastructure as a code is not when it's not possible to use infrastructure as a code to create on-demand environments. So first of all, when we hard code the names of our resources, when we have the definition of our resources that are written in strict way in our templates, for example, CloudFormation template, but in Terraform it's the same. We cannot create a number of our environments together. But if we have it parameterized, we can create such a thing. So it is the preferable way to do so. When we have some dependencies in our microservice, so for example, we have CloudFormation stack or Terraform module, for example, that is integrated with some services. It's fine when it's integrated and connected in the CloudFormation template in the scope of one CloudFormation stack. But when we are integrating our stack or our service with other dependency from the outside, but not as a parameter or as a configuration, but we are connecting them together from the infrastructure point of view, it is not possible to test one component or one stack in the separation. So it is the situation when we don't we are not able to test only this part of our software. Another scenario when it's not possible to test our one microservice or one particular module in our application is having so-called distributed monolith. So if we have our functionality that actually it's split into microservices, but the microservices as itself are not self-sufficient, we end up in testing the whole thing and are not able to test one particular service at all. Okay, so summing it up, we cannot write efficient end-to-end tests for our microservice, for our component, for our module, when the modules are not separated correctly. So if we have the distributed transactions or distributed monolith, it's not possible to test end-to-end tests very easily, because to write such a test, we have to create the whole big environment. If you are hard coding the specific names in our infrastructure as code templates, we are also not able to write those tests because we are not able to create separate environments for every use case that we want to test. And if we are hard coding dependencies, for example, when we are using some external database that is created in our other stack, and we are hard coding this dependency in our infrastructure as a code, it's also not possible to test it. And the very important thing is that the using parameters in our CloudFormation templates or Terraform modules is very important. So we want to parameterize everything that we want to just have most flexible deployments as we want. So summing up the writing tests for our software, for unit tests, we want to use stubs or mocks. And when it comes to writing the unit tests, it's very important that our tested code follows the clean code principles. And when talking about clean code, the inversion control is the most important thing here. So we don't want to have the situation when our implementation details depends on the concrete real usage, for example, database usage. In integration tests, we want to test our integration with other components, but integration like contracts. In component tests, we want to test the real implementation of the whole system, but with faked external services. So when we are testing our use case, for example, some command or something like that, we want to test the whole flow, but with usage, for example, of fake implementation like in-memory database. And the appropriate code architecture is crucial here. So for example, when you are using the hexagonal architecture, you are good here. And in end-to-end tests, we are testing the whole flow of the application, and we are not using any test doubles here. It's very important. So if we are testing end-to-end, we don't want to, for example, fake some implementation of the external service. It should be the real concrete appropriate external service that we are using in the production, but in the other version, for example. And coming back to the test pyramid, this is actually the test pyramid without the context of the cloud. And how do you feel? And what do you think? It is still the same pyramid for the cloud applications, or it is changing somehow if we are using the cloud context here? How do you feel? Okay, that's one opinion. That's my opinion too, but there is some hypothesis in the industry that if you are using the cloud and we are deploying the applications in the cloud, for example, using serverless or containers or so on, we want to have more and more component and integration tests, actually. So we don't want to have a lot of unit tests, but we want to have more integration tests. And I do not agree with that, because the argument for that is we are basing in the cloud on the configuration between services. So for example, often we are building, for example, serverless applications that are built as a sequence of Lambda functions connected with SQS queues. But it is true, but still, I think we need to stick to the unit tests and test as much as possible using unit tests. Okay, and right now, some myths and facts about testing, because this is very, very misunderstood topic in the industry, I think. There is some thesis in very often that you have the extraordinary case and you are not able to write testable software. Did you hear something like that? Anyone? Everything is very, very extraordinary, and our case is special. And actually, it is very funny, because I hear about it not only regarding testing. I saw in my career that someone was writing its own sorting solution, because his sorting solution is better than in the standard libraries, for example. I saw also the encryption of the files that are better than standard ones. Or we are inventing from the scratch Git branching model, for example. I saw it also, and I don't understand it actually. Do you know anyone from this slide? I know, I knew that. Okay, but anyone else from this? Okay, never mind. but it's good to not know them, but the publications and texts from them. I do not agree with that our cases are extraordinary. More, our problem is solved already. So we should seek the knowledge and be humble in our software development practice and just managing software and so on, because probably someone who is smarter than us solved this problem already. The second one, it's only MVP, and it's only for 1 month, and we want to validate something only. It's not important right now. The quality is not important here. Anyone heard about it? Yeah. Sure, and I can agree with that. If we are talking about writing the unit automated tests, and it is fair, of course, but it's like with the cloud. Sometimes we don't have to run the application in the cloud, but we want to have the possibility to run it in some point and be cloud ready, for example. So please write the software in the way that we are test ready. So we don't have to rewrite everything from the scratch, only to have the automated tests. So yes, it is. Sometimes it is not the time to have the automated tests, but it is not the excuse to writing the code that is not testable. I don't buy it. How the code that is not testable, writing the code that is not testable is faster than writing the shit code in the one function to have 500 lines of code. I don't buy it. Okay, and the last one. We don't know the requirements to write the tests and test every possible test case. It is also common thing. Sorry? Yes, but but you know you can write the code basing on some tickets, for example, but you don't have to. But you cannot understand the requirements. So you are writing just basing on the requirements that are in the ticket, but you don't understand the requirements. My question is, who of you is considering himself as an engineer? Most of you. Okay. And okay. I'm with you, but when we are talking about engineering, there are some areas in our world that are really engineering, and we like to see our job as a rocket science and writing some fancy code and so on. But sometimes it's not like this. It's more like coding the HTML in the cafe with soy latte. And in this case, we are not really engineers, in my opinion. We are more like labor workers of the 21st century. So if you are working in a software company, just try to seek the knowledge and go deeper into the requirements. So you are not writing only the code that are meeting the requirements described in the Jira ticket, but you understand correctly what is the purpose of it. Only when you understand what is the purpose of your software. Why? Yes, but those requirements are I agree with you, but I do not agree that writing the code that is not testable is faster than shitty code. I do not agree with that. Sorry. In automated way, not. This is the case. So writing the whole, for example, the whole API call in the controller for 500 lines of code, I do not buy it that it's faster than splitting it into the components and so on. So this is my opinion. Yeah, and I'm talking only about it. It's very broad topic. Yeah, I agree. I agree with your disagree, and we can talk about it afterwards. So, do you have any questions for this? Besides that, of course.